Let us look at playing card problems. A deck of playing cards is a set of 52 cards. There are 4 suits of 13 cards each. There is a suit called clubs. There are 13 cards of clubs. In those 13 cards, there are a few special cards. The A signifies the ace of clubs, and the J, Q and K signify the Jack, Queen and King, or the face cards of clubs. There are 13 cards of spades. Within those 13 cards, there is an ace of spades and 3 face cards of spades. Clubs and spades are also called black suits. Then there are 13 cards of hearts. Within those 13 cards, there is an ace of hearts and 3 face cards. Similarly, there are 13 cards of diamonds. There is an ace of diamonds and there are 3 face cards of diamonds. Hearts and diamonds are also called red suits. 13 cards in a suit, and as you can see there are 4 suits. 13 multiplied by 4 makes it 52 cards in a deck. The names clubs, spades, hearts and diamonds are derived from the symbols on these cards. We can also look at these 52 cards in a different way. There are 4 aces and there are 12 face cards, 3 face cards in each of the suits. Let us look at a problem. A card is drawn from a deck of 52 cards. What is the probability of the card being an ace? Recall that there are 4 aces in a deck of 52 cards. My total number of possible outcomes would be 52, as there are 52 cards in a deck. Since there are 4 aces in a deck, my number of favorable outcomes would be 4. So my probability of drawing an ace would be number of favorable outcomes divided by total number of outcomes, which is equal to 4 by 52 or 1 by 13.
Wow, the pictures really help.
Great! Let us try a few more problems then. Let us look at another problem. A card is drawn from a deck of 52 cards. Find the probability of getting a red face card. Recall that there are 12 face cards, 3 face cards from each suit. So my total number of possible outcomes is 52, as there are 52 cards in a deck. Out of these, there are 6 red face cards. So my number of favorable outcomes is 6. So my probability of drawing a red face card is number of favorable outcomes divided by total number of outcomes, which is equal to 6 by 52 or 3 by 26. Let us look at another problem. The ace, jack, queen and king of 4 suits are shuffled together and a card is drawn at random. What is the probability of the card being the king of spades? Recall that there are 4 aces and there are 12 face cards. So my total number of possible outcomes is 16 here because I am only shuffling the ace, jack, queen and king of 4 suits, out of which my number of favorable outcomes, that is the king of spades, is just 1 card. So my probability of drawing a king of spades from this set of cards would be the number of favorable outcomes divided by total number of outcomes, which is equal to 1 by 16 in this case. Why don't you try a problem on your own? One card is drawn from a well-shuffled deck of 52 cards. The card drawn is a queen of hearts and is put aside. Another card is drawn. What is the probability that the card drawn is a face card?
A card is put aside Does that mean there are 51 cards now?
Brilliant, Ayush. Yes, the total number of outcomes shall be 51 now.
So I should reduce 1 card from the 12 face cards also?
Awesome! Yes, the card put aside is a face card. You continue to surprise me. Go ahead and try other problems from your textbook. If you need more help, check out the question bank.
Oh yes, now I know I can ask you if I'm stuck. Thanks, Miss Owl.